In this video tutorial, we are going to build a sample decision diagram in Blazor. We are using the MindFusion flowchart component for Blazor. Nodes and links are created and labeled on a random principle. We start with a new project. There are two options: the Blazor WebAssembly or a Blazor web app project. Both are possible. There are slight differences as to how you integrate the diagram component. We decide to go with the web app project, which consists of both server and client side. Indeed, it is important that you choose Auto as the interactive rendering mode. The steps on how to integrate the diagram in both types of projects are described in detail in the online documentation. We don't need HTTPS, so let's add the MindFusion Blazor component as a NuGet package. You only need to do this in the client project. The server project does not need a reference to the diagramming component in order to render it. Next step is to create a new Blazor component, where all diagramming rendering and logic shall happen. First, we add the directive Render Mode Interactive WebAssembly. This is important. Then, we declare the namespaces we are going to need: Maui Graphics and several diagramming ones. Time to declare the diagram view component. It is important that we give the element that hosts it explicit size. Since the diagram is empty, by default it might render too small, so we embed it in an HTML element that is explicit size so it can resize the diagram view as well. In our case, we use a grid display for a div element that makes it take almost all the page. We also need a button which, when clicked, will generate different random decision diagrams. We declare now the diagram view variable and initialize the diagram. Before we can run our sample project to check the results so far, we should add this Blazor component to a page in the server project. In our case, it is the home page. And now we have a big diagram area, where we can create nodes and connect them. The default diagram is its default behavior. Let's define some beautiful brushes and earth tones now. We will use them to style the diagram items. We want to use some fancy fonts. Since Blazor apps run in the browser, by default they can only use the standard web fonts. If we want to use any of the system fonts, we need to embed them into the application. We want to use the Open Sans font in bold. We copy all the Open Sans font definitions into the client folder of our project. You can find the font in the Fonts directory on your computer. Then we make the font we want to import an embedded resource. We write the load fonts method, where we access the current assembly and read the font as a stream. We also need the system reflection namespace. We also need to call MindFusion Font Manager and provide him the stream we read from the assembly. Let's handle now the click event for the button. In the event handler, we are going to create a random diagram. First, we clear all diagram nodes that might have been created with a previous button press. Then, we create two new shape nodes, Start and End. We use plenty of properties of the Shape Node class to customize these nodes. You can look up all the properties of Shape Node in the online documentation. Note that we create the nodes with the factory class. It creates and automatically adds them to the diagram. We add now some variables used by the auto-generation of different decision diagrams. Let's go briefly through the auto-generation code, which is not so important. When you build your own decision diagram, you most certainly won't build it on a random principle. We use random numbers with a variable seed to guarantee that the count of nodes, links, and their labels vary between each button press. Then we use the factory class to create two different node types, decision and operations. Links among them are created on a random principle. When we run the sample, you will see all nodes and links in one place. That's because the nodes were created with the same coordinates. If you use a layout algorithm, the initial bounds of the nodes don't matter. So, let's apply the decision layout and see what a difference it makes to the diagram. We define the arrange diagram method, and there we create an instance of the decision layout class. We use some of the algorithm's properties to customize the final result. Each layout algorithm exposes a variety of options that affect how the diagram is arranged. With the layout applied, the end result looks much better. A lot of links lead to the end node, and this might look ugly at times. We can fix that by applying an anchor pattern only to it. The anchor pattern property defines the relative positions where links can come in and out of the node to which it is assigned. The node coordinates are described relatively from 0 to 100 along both axes, x and y. So, in our case, we define a lot of equally distributed anchor points along the right side of the node. Let's assign this pattern to the end node. And now the incoming links get arranged much more neatly. You can see the anchor points along the border of the node. What we are left to do is apply some styling to the diagram links. We use the diagram link style class, which is also exposed as a property for the diagram instance. We apply some brushes and pens, stroke thickness, and font for the labels. There is also an option to customize the head of the link, as well as its base, should you need that. We only use head for our links. And our decision diagrams look really appealing now. Nodes and links are well arranged, the diagram has nice colors, and labels appear in a pretty font. With that, our tutorial is finished. Thank you for watching, and thank you for your interest in MindFusion developer tools.